years ago we met, and you were at a CES as well, and you were doing some really interesting things in the home with distributed computing. Yeah. Well, now it looks like you've kind of gone beyond the home and doing even more interesting things. Why don't you tell us what this massive machine is here behind us, and we'll have a conversation.
Basically, this is a small part of our machine, and we're still doing distributed high-performance computing, but we're doing this at a larger scale. Basically, what you can see here is just a part of our machine here. So what we designed, the product is called the QBX. Imagine it's a kind of machine with inside 12 high-performance computing servers, very standard OCP computing servers. Then you have cold water coming in. The cold water is going to cool down and to retrieve the heat of the servers, and we have hot water coming out at 65 degrees Celsius. And so we are retrieving 95% of the heat of these servers. And then we're installing these machines, these QBX, directly on places in need of huge quantities of heat all year long, like big swimming pools, spas, or district heating networks. And we're installing 20 up to hundreds of units. Basically, we are doing a kind of small edge data center dedicated to HPC, but we are doing this data center on the right place and with the right heat recovery technology. And on the other side, we have clients using this computing power. So we designed a kind of totally integrated and intuitive platform for high-performance computing. It's a kind of one-stop shop for simulation engineers who want to launch simulations to develop a product, a car, a space launcher, a plane, whatever. Because when you are developing a product, you need to simulate your product on computers. And the more computers you can access easily, the faster you will develop your products. So these people are interested in computing power, accessing easily to hundreds of machines at the best price, and if possible with a sustainable approach. And that's what we're offering.
So what is the kind of bandwidth and latency requirements that you need to get this?
It's not really, we don't have really problems of latency, because when you are doing a simulation, in the development of a product, it's not a problem if you have your results like 1 second or 2 seconds later. It's not like algo trading or gaming, it's not real time. It's not real-time computing. It's what we call batch computing. So in these cases, there is no problem of latency.
And what about from a bandwidth perspective? Are we looking at gigabit requirements?
Sorry?
Oh, from a bandwidth perspective, what are you looking at?
Yeah, we need several gigabytes of bandwidth, of course, because the quantities of data for the simulations are quite important. But it's not like, it's not to be. Generally, on all the sites we're installing these machines, the swimming pools, the district heating networks, we have all the bandwidth we need generally.
Well, and then how does the business model work? Are you guys supplying the customers and the equipment?
No, the business model also changed over the past years. Exactly 2 years ago, what we are doing, we are able to finance today the installation of the machines, and what we do, we are selling the heat to the sites, and we have contracts with all the sites in Europe. So far, it's in Europe only. We are signing contracts over 20 years. And the sites are committed to buy our heat over 20 years. And this heat will finance all the infrastructure installation, okay? And then we are also selling, of course, the computing power. So we have revenues from the heat, we have revenues from the computing clients. So, and we are not building a data center. So we don't have all the CapEx and the OpEx of the data center. And that's why structurally we are able to propose computing power at like 2 times less expensive that you will find on the market. So, because by design, we are cheaper.
From a structural standpoint, security and so forth, the physical security, can you just put this in a pool room, or what do you do?
No, actually physical security is very good, because when we are on a district heating network, it's a critical facility, So generally, if you go to visit a district heating network facility where they are also generally producing electricity, it's more secure than the data center, okay? So basically, the site is already secured, and then the place, the technical room where we are placing our units are also secured. So the physical security is as good as in a traditional data center, even better, I would say.
And you're saying from a model perspective, you need a certain kilowatts per year to make this work?
Yes, to qualify a site, we need a minimum, what we call a base load, you know. District heating networks are consuming several megawatts in winter of heat, but even in summer, we need the consumption in summer because we need to make our computers work all year. So basically, we are addressing what is called the base load of the site, and we need at least 200 kilowatts to qualify a site. If there is no consumption of heat in summer, it is not the site we will install the machines.
And so these are available in Europe today. When do you expect them in the US?
Soon, I hope so. Today in US we have technological partners because we are working with AMD, with Intel for the hardware. We are also looking for simulation clients. Because any people developing products are potential clients of the platform. And of course, the second step will be, yes, the installation of physical facilities in the US. But so far, the playground for this is very big in Europe, but it depends. If you have an opportunity to do that, we will come, of course.
And speaking of physical footprint, how much room are we talking about here? Is this a half a rack or a rack equivalent?
Yeah, I would say if you look at the computing power, it's a rack, yeah. Because even in high performance computing, with a full rack, it depends on the power of your computers. But generally, you cannot switch on all the computers in a rack because of the capacity to cool down. It depends on how it's cooled in a traditional data center. But generally, yes, if you take one unit, it's the equivalent of a rack.
And I'd imagine you need not only electrician help, but you need a plumber too.
Yes, absolutely. But all this, we can subcontract this to the sites because the site where we are installing a district heating network, they have their own people for the maintenance, for the plumbing, everything. And so all the installation and the maintenance is subcontracted to the sites.
Excellent. Well, I wish you luck as you move forward with this new product. And,
yes.
and before we leave, you said you still have, in France, you have a number of the distributed heater solutions,
yes, we're still maintaining 3,000, we are heating 3,000 households in France with this system. So it's, we still maintain that, but we're not selling more additional units. Because on these heaters, we can do like computing for banks or 3D animation, but we cannot address the clients performing simulations, on softwares like ANSYS. Technically it's not possible.
And as I recall too, one of the inherent security features of your product is the fact that it's distributed computing. So even if someone steals the hardware, they don't get a lot, right?
Yeah, right. Totally. It's totally that. Yeah. So, yeah.
Excellent. Well, I wish you continued success.
Thank you very much. Thank you.